Welcome to HP Tuner's Ford Gen 1 Coyote Training Part 17. This training module, we're going to look at the basics of working with our mass airflow calibration and tuning process. So if we've changed our intake from stock to an aftermarket intake, we need to go in and rescale our mass airflow curve so that it's going to be representing the correct amount of airflow or air mass coming into our engine. Everything hinges upon this calculation being correct in our Ford PCM, so we have to make sure it's done properly. We're going to go over a whole bunch of details here. Let's jump in so we can check this out. Okay, so let's get started. We're going to be taking a look at working with our mass airflow sensor and programming within our Gen 1 Ford Coyote PCMs. Now, the mass airflow sensor is a critical sensor in the Ford programming. We have to make sure that it's calibrated right, because if we don't register the proper amount of airflow, it won't deliver the proper amount of fuel. It also won't calculate spark timing correctly, and it also won't calculate torque correctly. All of those will make a huge difference in the way the car drives and runs. If we don't have the MAF curve calibrated right, it does not report the correct airflow. So we're going to learn how to work with the mass airflow calibration curve, understanding what it represents, and then going into some associated tables that we have to go and turn off and some of the logic we have to go and alter in order to make sure that we're riding just purely on the mass airflow and not working within the complex algorithm in the background associating MAF and speed density. There is a speed density type of calculation. That's the estimation of airflow that would come from a MAP sensor. Now, in the Gen 1 Coyotes, they don't have a MAP sensor present, so it actually calculates or infers the MAP pressure reading to be able to work with a speed density type of logic, again, going on in the background, based on the mass airflow sensor. It's kind of a circular type of relationship it has. It's a hybrid relationship between mass airflow and speed density MAP pressure based reading, but the MAP pressure is calculated and it is based on the mass airflow. Sounds a little bit confusing. We're sticking to just MAF in this tutorial, so we'll get into the speed density a little bit later in the training course. Let's jump in and take a look at where we can find the mass airflow sensor right now and break down and understanding what is going on with the mass airflow sensor, how it works, why it's important, and what we need to do to calibrate it properly. Okay, so the first thing we're going to do, I have a 2013 Mustang GT file open. We can find that right here. Any 11 to 14 file that I provided in the example folder in our course packet will be fine to open up so you can follow along in this training tutorial. So I'm going to go in here to my engine tab, and from engine we're going to move across here to airflow and then into the general tab. Now in our general tab, we can move over here into our MAF calibration area. This is everything related to the mass airflow sensor. We're going to have to turn off and on some of these toggles when we're dealing with calibrating our MAF curve. We're going to be getting into that in a little bit, but this is the area that we jump to when we want to make any mass airflow changes. Now, we also have a couple other things such as a desired air mass. This is part of the speed density calculation, which we want to turn off when we're tuning our mass airflow sensor, because again, the speed density is hinging upon the mass airflow reading right. If the MAF isn't calibrated, then you can't use the speed density. Definitely a confusing relationship we have going on with speed density. Again, we'll get into that in another tutorial. Right now, let's focus on the mass airflow. So in looking at our MAF calibration, we have these two tables here, airflow versus voltage and MAF airflow versus period. If you're used to working with the 2010 and older Ford PCMs, those have a mass airflow sensor that is a voltage-based signal. 0 to 5 volt is what they output, and depending on what the voltage is reading, it'll associate the voltage to a certain amount of airflow being ingested into the engine. If we take a look here at airflow versus voltage, you can see exactly what I mean. At something like a low voltage, 0.8 volts, we are saying here this would be 0.644 pound per minute worth of airflow. Let's change this over to grams per second. Find it a little bit easier to take a look in units of grams per second. So in this case, 0.8 in our voltage would be associated with 4.87 grams per second. If we look at a higher voltage, 4 volt, this would be 184.87 grams per second. So on the older MAF types in this calibration lookup, it is going to be a one-to-one lookup where the MAF sensor outputs a voltage based on how much flow is going across the sensor, and it's going to look up what that amount of air mass is going to be in grams per second, or whatever the unit scale is going to be, whatever the unit scale you have it set up in your table as. So it's pretty straightforward. Now, the newer Ford PCMs, so the Gen 1 Coyote PCMs, Ford has switched over from a voltage type of MAF to a digital type signal, and we can find that mass airflow versus period. this is the table right here. Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.